Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about concept of power spectral density and relationship between autocorrelation function and auto power spectral density of a random process x of t. So now here in this video, I am going to discuss about some important properties of power density spectrum or properties of power spectral density. And the first property is the zero frequency value of the power spectral density of a wide sense stationary random process is equal to the total area under the graph of the autocorrelation function. So that is Sxx of 0 is equal integral minus infinity to infinity Rxx of tau d tau. So this is the first property. This is the statement of the first property. Now coming to the proof. So we know that from the linear-Kinchin relation, the power spectral density of a random process x of t is Sxx of omega is equal integral minus infinity to infinity Rxx of tau into e power minus j omega tau d tau. So in this equation, substitute tau is equal to 0. If tau is equal to 0, e power minus j omega into 0, e power minus 0, e power minus 0 value is 1. So therefore, if tau is equal to 0, then Sxx of 0 is equal to integral minus infinity to infinity Rxx of tau d tau. Sorry, not tau is equal to 0, omega is equal to 0. Substitute omega is equal to 0, then Sxx of 0 is equal to integral minus infinity to infinity Rxx of tau d tau. This is the first property. And second property, the power density spectrum or power spectral density of a wide sense stationary random process is always non-negative. That is, Sxx of omega is always greater than or equal to 0 for all values of the omega. And third property, the mean square value of a wide sense stationary random process is equal to the total area under the graph of the power spectral density. So that is expectation of x square of t is equal Rxx of 0 is equal 1 by 2 pi integral minus infinity to infinity Sxx of omega d omega. So now coming to the proof. From the linear-Kinchin relation, the inverse Fourier transform relation Rxx of tau is equal 1 by 2 pi integral minus infinity to infinity Sxx of omega e power j omega tau d omega. In this equation, substitute tau is equal to 0. If tau is equal to 0, then Rxx of 0 is equal. So substitute tau is equal to 0, e power j omega tau is 1. Okay, remaining RHS term is 1 by 2 pi integral minus infinity to infinity Sxx of omega d omega. But we know that Rxx of 0 is the uh, Rxx of 0 is the mean square value of the random process. That is expectation of x square of t. So Rxx of 0 is the expectation of x square of t. So this expectation of x square of t is equal to Rxx of 0 is the one of the property of the autocorrelation function. So from the property of the autocorrelation function, Rxx of 0 is equal to expectation of x square of t. Next property, the power spectral density of a real valued random process is an even function of frequency. So that is Sxx of omega is equal to Sxx of minus omega. So this is the statement of the proved property. Now coming to the proof. So we know that using linear-Kinchin relation, the power spectral density Sxx of omega is equal integral minus infinity to infinity Rxx of tau e power minus j omega tau d tau. In this equation, omega is replaced by minus omega. We get Sxx of minus omega is equal. Okay. Uh, so omega is replaced by minus omega. Now we are Okay. So integral minus infinity to infinity or xx of tau. So omega is replaced by minus omega. Here already minus is there. After substituting omega is equal to minus omega, minus into minus plus. We have e power j omega tau d tau. So now replace tau by minus tau. We get in the above expression tau is replaced by minus tau. We get sxx of minus omega is equal. So now here what are the ranges of the tau? Tau ranges are minus infinity plus infinity. So when you substitute tau is equal to minus tau, the ranges of the tau are plus infinity to minus infinity. So that is integral plus infinity to minus infinity r xx of minus tau e power minus j omega tau d tau. So substitute tau is equal to minus tau, d tau is equal to minus d tau. Okay, once again I will explain RHS term of this equation. So in this equation, tau is replaced by minus tau. So tau is replaced by minus tau. The ranges of the tau are, the new ranges of the tau are plus infinity to minus infinity. So d tau is equal to minus d tau. So, but we know that according to basics of the mathematics, minus integral plus infinity to minus infinity function into dx is equal integral minus infinity to plus infinity function into dx. So we know that minus integral plus infinity to minus infinity function into dx is equal to integral minus infinity to plus infinity function into dx. So using this expression minus integral plus infinity to minus infinity function into d tau is written as RHS term. My integral minus infinity to infinity function into d tau. So that is sxx of minus omega is equal integral minus infinity to infinity rxx of minus tau e power minus j omega tau d tau. So we know that one of the property of autocorrelation function of the random process Rxx of minus tau is equal to Rxx of tau. So using this property from the above expression Sxx of minus omega is equal integral minus infinity to infinity. Substitute Rxx of minus tau is equal to Rxx of tau. We get integral minus infinity to infinity Rxx of tau e power minus j omega tau d tau. So the RHS term of this equation is core spectral density of the random process x of t, that is xx of sxx of omega. So this is the fourth property proof. The next property is the core spectral density of the random process is always real since xt of omega is real where xt of omega is equal expectation of xt of t. Next property, the power spectral density of the derivative of the random process is omega square times the power spectral density of the random process x of t. That is s x dash of omega. X dash is the derivative of the x of t. That is x dash is equal dx of t by dt. S x dash of omega is equal omega square into sxx of omega. So these are some important properties of power spectral density of a random process x of t.